So before you begin this test, remind yourself how gravity is affected by mass and distance here, and then draw or describe an orbit that is elliptical here. We talked about this in class. Just a reminder, these will be part of your answers later in the test. Now begin the summative task. Go to the gravity and orbits PhET simulation and follow these steps. First thing is you click on scale. So let's do that. Okay, so we click on this one. All right. Okay. Then click the mass, path, and grid buttons for each time we do this test. So here we go. Mass, path, grid. So those buttons will be on every time. Click on play to start the planet movement. And when you're done with that particular test, you click on the orange reset button in the bottom corner. So the simulation is currently on the following settings. The star mass is our sun, planet mass is Earth, and the initial distance is 2 grid squares from the center of the star. So let me show you that. The star mass is our star, it's our Earth, and look at the distance 1, 2. Remember, you can scroll out and you can scroll back in, right, to get a better view of this. Okay, so now you're going to change the settings in the first column of the chart. So the first thing you're going to look at is a change in the star mass. So we're going to do a control. We're going to compare everything to this one. So you, first of all, you would do a test and you would look at the shape of the revolution, the speed. Is it slow or fast, constant or changing? And the number of Earth days for one revolution. So here we go. Remember, it started right here. I'm going to zoom in a little bit. So it starts right here. I would go, boom, start it, pay attention to the path, right? Maybe go up and have it go a little faster. And then when it gets towards the end, you can slow it down, right? Okay, slow motion so that when it gets to the end of its, there we go. Okay, so now you look at the shape, right? You look at the shape. Is it circular? Is it elliptical? What is this? And you write it down. Is it slightly or very elliptical? Did it go slow or fast? Eh. And the number of Earth days. So kind of constant, right? Then here's where you do the different one. You change the star mass to 2, and then you do it again. You change the star mass to 0.5. So for example, you would reset it, click the mass, path, and grid, and set the star mass to 2, right? And then see what happens. I'm not going to go through that because that's your job. But this is how you go through it. Then you're going to change the planet mass. So the next time you do it, you would change the planet mass here. All right. Sorry. Then you would change the distance. The distance is 4 squares. So for example, go here, reset it, make sure I have the grid, path, and mass. Now I have to zoom out so that my planet is 4 squares away. Right now it's just 2. 1, 2, 3, 4. Here we go. So that's how I change the distance. All right. And then I can make it go closer. And then at this last one, I change the mass and distance. So the star mass is 2, the planet mass is 2, and the distance is half a square. So they're very massive and very close together. Here's where the grade comes in. In a short paragraph, explain how the mass of the star affects the planet's speed, orbit shape, and revolution time. Now, include evidence. In fact, I'm going to add this to this. Include evidence from the chart. Okay. Explain how the mass of the planet affects the planet's speed. Explain what happened and why when you changed everything. And here's where you use the claim. When I changed everything, when I changed everything, explain what happened, use your specific evidence, and then explain what you know about gravity, mass, and distance to answer the question. All right, if you have any questions, let me know. But this right here is where you're going to be really graded on how well you use the evidence from your chart. So use specific numbers and ideas. Okay, good luck. And again, ask me if you have any questions.